latest version of the Blackfly Ultralight is attracting a lot of attention inside the Innovation Showcase this year at AirVenture 2018. We caught up with Alan Eustace from Opener to tell us more about the aircraft.
10 years ago, our founder and CEO, Mark Sling, had an idea. He had a successful manufacturing business for many years. He was on a boat in the islands with a pencil and paper, and he realized some amazing things, that battery technology had reached a point, and electric motor technology had reached a point, and carbon fiber technology had reached a point, so you could actually build an aircraft out of those components and fly it. He built a prototype showing that those combinations of components were possible to fly, and that's what we have over here. So during the lifetime of the company, which has been about 10 years, they built over 20 aircraft and refined the concept from the initial one that he built now, and this is the pre-production version of the latest and greatest. It's got 8 electric motors on it. It's got battery systems for each of those. It's made out of composite technologies. It's very lightweight. So lightweight that it actually fits in the ultralight category, usually with things like powered parachutes and things. But this is a fully capable vertical takeoff and landing aircraft that is extremely efficient, and that's the first time that the ultralight category has ever seen an aircraft this level of capabilities. It's got wings, a front and rear wing, and that makes the vehicle much more efficient because during cruise flight, much as in an aircraft, the wings are actually providing a lot of the lift and the motors don't have to. So that's what makes it, amazingly efficient. Various different jurisdictions have different weight limitations, and so in the US, the ultralight regulations restrict you to essentially 62 miles an hour, so that's what it flies in the US, and it restricts the weight down to the point where we can fly with about 25 miles before a recharge, and that's with a 25% reserve. It was built completely with safety in mind. Matter of fact, the previous aircraft, the one that's outside, has flown for 10,000 miles. It can either be flown remotely or it can be flown autonomously, and all the testing was done that way. We did over 500 takeoffs and landings where we fail engines at the worst possible time so that we can guarantee that we can safely get the occupant back to the ground, and all that testing was done before we put the first human being into it, which is also extremely unusual. The way this aircraft is set up is you have electric motors. They're very small, 4 pounds. They generate 130 pounds of thrust each, so they're incredibly powerful motors. The batteries are actually right behind them, as are the motor controllers. We put the batteries next to the electric motors, and the reason for that is it's easier to distribute the power, but more importantly, there's a safety concern. So by putting the motors and distributing next to the things, they're way away from the occupants. We took one of these motors and ran it in exactly the configuration of flight. So you start it up at high power, you cruise, you go into high power for landing, and we did that over and over again for 3.5 years. One of these motors lasted for 3.5 years and over 20 circumnavigations of the globe, if there was an actual aircraft flying, with 0 failures. And we've actually made a lot of improvements in that motor since that time. Now it's on a plaque on the wall. So incredibly powerful motors. The batteries are redundant. There's two batteries per pod for each engine, and we're constantly monitoring the state of the batteries so that if there's ever a failure, we know about it. We can shut down a battery. We can use the other battery. You can also use adjacent batteries. So there's a lot of redundancy. The entire control systems are triply redundant. So we have 3 different buses in the wings, actually separated physically, so that if any one system fails, we have redundant systems for the control systems and things like that. The vehicle charges, I mean, if you have a regular 110 outlet, it'll take about 7 hours. If you have a dryer style outlet, you can get that down to 1 hour, and we have supercharging capabilities that'll get it down to 30 minutes. flies for, you know, in the US, based on the smaller battery size, it flies for about, you know, 25 miles at 60 miles an hour, so it's about 23 minutes, and that includes reserve. So if you reach that, there's plenty of power remaining for us to do emergency landing or something like that, get you down safely. The entire charging system holds about 8 kilovolts, which is, you know, depending on where you live, you know, $1 or $2 of electricity. These motor systems almost never fail, so the reliability, we feel like, is going to be super high for these kinds of systems. I think the regulations at some point will catch up, where you'll be able to fly in more and more places, but right now the restrictions are anywhere that you can fly an ultralight. I think most people will get them because they love to fly. They've always wanted to fly. They haven't been willing to spend the thousands of dollars to get a pilot's license in the year, and you know, but they've dreamed about flying since they were a kid. So I think that's probably the majority of the people will finally have a chance to fly an aircraft that they've never done before. It's a single occupant aircraft. We have an amazing virtual reality simulator. We can take somebody that's never flown before and we can get them to fly this airplane in the simulator in 5 minutes, and a longer training program for somebody who's actually owning them. Pilot range from 6'6" and 250 down to normal sized people like me. I mean, eventually this kind of aircraft could do a lot of things. You know, it's got autonomous capability, so you can take it to and from anywhere. You could use it for rescue. You could use it for urban transportation. You could use it to do Uber or Lyft style things. The capabilities are large. There's another possibility. You could imagine it being certified instead of under ultralight, under experimental, which would allow pilots to be able to have more capabilities with the aircraft, and we'll explore various things like that. But I mean, the possibilities are really pretty much endless. So right now, this is a pre-production model. We're actually going to do the same 10,000 miles of testing, the same redundancy testing, the same safety testing. All that's going to happen. All the failure mode scenarios are going to happen before the first person flies in it. But we think that's going to happen in a reasonably short period of time, and we'll be ready to sell these vehicles in 2019. The cost, you know, will be a big range from cheap SUVs to big SUVs, but somewhere in that range so that everybody can afford one. If you'd like to learn more, we have a website. It's www.opener.aero, and there's videos on the site, there's technical specifications, so if you want to learn more, please go to our website.